Okay, year 12. So far we've looked at arithmetic sequences. Today we're going to be looking at geometric sequences and then geometric series. So to start with, quick recap of the difference. Sequence here is an arithmetic sequence because it's got a common difference d, we're adding on the same amount each time. A geometric sequence is one where it's got a common ratio and we multiply by the same amount each time. So this note at the bottom here is probably useful to get written down. A geometric sequence is one in which there is a common ratio between terms. So first of all, can you identify all of those common ratios? Hopefully yes. So sorry, let me just change my pointer. Here the common ratio would be 2, we're multiplying by 2 each time. Here the common ratio is 2/3. Here it would be 1/2. Here it would be -1. And this would make an alternating sequence. This one here would be -2x. This one here would be p. And then finally it would be -0.25. That's how we get from one term to the next term, so we multiply that. So the nth term for an arithmetic sequence we looked at last time. Today we're going to look at using the formula for a geometric sequence, which is this. It's a times r to the power of n minus 1, where a is your first term, r is your common ratio, and n is the position in the sequence. So here, for question 1, a is 3 because that's the first term in the sequence. R is 2. So to find the nth term, we would do 3 times 2 to the power of n minus 1. You can't simplify that, that just is the nth term. And then to use that to find the 10th term, we would do 3 times 2 to the power of 10 minus 1, which is 9. And then I would evaluate that using a calculator, which is 1,536. For the second one, a is going to be 40. My common ratio is going to be, well, what are we multiplying by to get from 40 to -20? We are multiplying by -0.5. And so therefore my nth term is going to be 40 times -0.5 to the power of n minus 1. Again, can't simplify that. Then my 10th term is 40 times -0.5 to the power of 9. Inputting that into my calculator now gives an answer of -0.078125. And so that is the 10th term of that sequence. Okay, so slightly harder example then. We are told here that the second term for geometric sequence is 4, which therefore means u of 2 is 4. And we also know that u of 4 is 8. Therefore, if I write this in terms of my nth term, which for geometric sequence is AR n minus 1, A we don't yet know, R we don't yet know, but here n minus 1 would be 2 minus 1, which is just 1, and that is 4. Here we would get A times R to the power of 4 minus 1, which is 3, which is 8. I'm going to call this equation 1 and equation 2. If we do equation 2 divided by equation 1, then what we get is this. Therefore, this cancels, leaving us behind with r squared. So we get r squared equals 2, and therefore r is root 2. It can't be negative root 2 because r is positive. So that's our answer to part A. The common ratio r is root 2. Then for part B, we want to find the first term. Well, this should be quite straightforward, right? Because we already know that we've got 4, then we've got something, then we've got 8. So to find this term, the first term, we would do 4 divided by root 2 to get back to it. So when I put that into my calculator, we get 2 root 2. So therefore A is 2 root 2. And then finally for part C, we want to find the 10th term. So to find the 10th term, I'm going to use a times r to the power of n minus 1. A is 2 root 2. R is root 2. The power here will be 9. When we input that into our calculators, we get 64. And so part C is 64. Okay, so this example then. We are told the numbers 3, x and x plus 6 form the first 3 terms of a positive geometric sequence. Now with the geometric sequence, it's got a common ratio. It therefore follows that the second term divided by the first term would be the same as the third term divided by the second term, like that. So then we can solve this equation by cross multiplying. Oh, I should have written that the other way around. This factorises. And so we get 2 different values for x could be. Either x could be 6 or x is negative 3. In this case, though, we are told it is a positive geometric sequence, and therefore x needs to be 6. Lovely. For part B then, we want to find the 10th term in the sequence. So we are going to use a times r to the n minus 1. Here, the first term in the sequence is 3. Now my common ratio, let's just think about it for a second. We know x is the number 6, and we know that this term is 12. So my common ratio is 2. So it's 3, sorry, I don't know why I've written that there, times 2 to the power of 10 minus 1. So 3 times 2 to the 9, which therefore gives 1,536. Okay, so final example then. What is the first term in the geometric progression to exceed 1 million? Now, starting point, let's establish what the nth term would be. So here, my nth term is going to be a is 3, the common ratio is 2, the power of n minus 1. So this is my nth term. Now, we want it to exceed 1 million. So I would write 3 times 2 to the power of n minus 1 is greater than 1 million. And now this is an equation that we can go about solving. So first step, let's divide by 3. Sorry, I'm going to forget 0 here. Okay, now we've got that. To solve this sort of equation, we are going to need to use logs. So we can log both sides of our equation now. So we get log 2 n minus 1 is greater than log of 1 million over 3. Then we can use our power law for logs. So this n minus 1 can come to the front. So we get n minus 1 times log 2 is greater than log 1 million. So I'll try it out. Over 3. Now it looks like that. We can divide both sides by log 2. So we get n minus 1 is greater than log 1 million over 3 all over log 2. I would probably input that into my calculator now. Give me just 1 sec to do that. When you input that into your calculator, you get 18.35, like that. We can add 1 to both sides, giving n is bigger than 19.35. And so therefore it's the 20th term that will exceed 1 million. The 19th term won't, but the 20th term will be the first term in that progression to exceed 1 million. Right, with that in mind, year 12, have a go at exercise 3C now, marking your work as you go. As ever, if you want to skip the first few questions and just like work from like 8 onwards, that's absolutely fine.